to IoT Asia. Welcome to the future of intelligent manufacturing. My name is Saj Kumar. I'm the regional business lead for manufacturing in Asia. Before we start, I'd like to talk about the impact of IoT and intelligent manufacturing. IoT is what connects all the equipment, the sensors, so anything that you see in the real world that needs to be brought or elevated to bring about a decision in operations to drive an intelligent manufacturing plant would need to come from an IoT sensor. So all of that capability is enabled by the IoT platform and IoT services. The challenges that we see in manufacturing industries today, as per a McKinsey survey, ranges from material shortages to demand drops to worker shortages to cash flow issues and planning issues. And some of the steps that can be taken to mitigate these, especially in the material areas, to have end-to-end visibility in the plant, creating war room environments in the plant to solve these problems, and looking at additional sources of supply. Post-COVID, we've seen increased adoption of Industry 4.0 technologies, and the rapid pace in adoption has only been accelerated by COVID. And we're seeing areas like work instructions becoming more digital. We're seeing performance management using IoT becoming more prevalent in manufacturing. We're seeing augmented reality being adopted more and more in many industries with HoloLens 2, where remote experts or engineers are not able to travel down to the customer location. We're looking at retrofit of plants to make it more automated, warehouses becoming more automated. We're looking at maintenance becoming more digital, so data-driven maintenance or data-driven activities around condition-based and predictive, eventually getting to prescriptive maintenance. And then we get into more advanced areas like machine learning and operations and robotic process automation. When you look at the trends that are driving intelligent manufacturing, we see three trends. Number one is the convergence of IT and OT. Whilst this is an old topic, what is happening more and more now is that the old definitions of an IT world where you had a single monolithic system, or in the OT world where you had a single MES platform, you now have a variety of systems in the IT world, from PLM systems to supply chain systems to quality systems to procurement systems. And in the OT world, you have the MES, you have newer types of sensors coming into play, you have newer machines, you have some old machines that have not been connected. So when you bring about all of this, you have this classic IT-OT bridge that needs to be connected and brought into a single common data platform or a common data model that defines the world of manufacturing. Secondly, the area of machine learning has become more and more important in manufacturing. And this is where we get to more interesting areas beyond the classic machine learning, where we're using optical inspection with image recognition as one of the key drivers in quality control, for instance, or using cognitive assistance for operators. Moving to more advanced areas like what we call autonomous AI, or driving autonomous AI for specific machines, whether it's a wafer fabrication plant or whether it's a CNC machine. So these are areas where we're seeing machine learning being applied more and more. All of them, of course, driven by data that's coming from the shop floor. Lastly, the area of process automation, which is driven by machine-driven automation on the shop floor with robots and warehouse automation, getting into the process automation area on the IT side, and now getting more and more into the OT world, is the ability to build an entire workflow of automation with almost a touchless end-to-end process, where a single bot could drive an engineering change order from R&D through manufacturing, or drive an entire quality control process through a quality control bot through the quality section as well as manufacturing. And this is where we're seeing process automation becoming more and more relevant today, when you have challenges of people being able to collaborate in this environment. Our vision for building more agile factories is driven across three levels or three layers, from a connected layer to a predictive layer to a prescriptive layer. So in the connected area, we're looking at workforce transformation, modern devices. In the predictive layer, we're looking at operational intelligence, process and workflow automation. In the prescriptive layer, we're looking at resource optimization, autonomous systems, all of them driven by the Microsoft Azure platform, from IoT to digital twins to our Teams collaboration to Dynamics, and also using our devices such as HoloLens and Surface. Let's look at workforce transformation. When you talk about workforce transformation, we're looking at equipping our first line workers with powerful and intuitive tools to deliver a safe and secure business experience. So that looks at productivity, it looks at health and safety, looks at process automation, looks at learning and knowledge management, especially for new workers coming in or cross skilling existing workers. And this is all driven by our teams and security platforms to ensure that this happens. One example of this is our customer in Iceland, Alcoa. And during the COVID times, they had to change from 3 shifts to 2 shifts. And in those 2 shifts, they had to ensure worker safety and productivity and ensure that people are checking in at the right location, the right people are checking in, and ensuring that you have that safety consciousness, wearing the right PPE gear. So we use the shifts capability within Teams to ensure that the first line workers are all connected on a single platform, communicating on a single platform, and receiving important information on that same platform. And that's how Alcoa was able to get over this crisis using the platform. The second area is in terms of modern devices, sensors, so where we're trying to enable workers with HoloLens 2 that gives them the best experience for collaboration and productivity, being able to share that contextual information by digitizing processes that used to be paper-based. What we try to solve with that is areas like remote assistance, where engineers are not able to travel down, training and task guidance to bring people up to speed, getting an engineer to look at a new work procedure or getting a new employee on board, collaborative visualization when you have distributed teams between R&D and production, when you want to introduce a new product on the shop floor, how do you do that collaborative visualization? And then lastly, the contextual data access, where when you're looking through a HoloLens, you actually get contextual information about that area, whether it is a hot working area where you get temperature warnings, or where you get areas about moving equipment, the rotating equipment where you have to be careful, all of that driven by a parameter of safety that ensures workers are protected at all times. I'd like to walk through a video right now and explain how this works in a customer environment.
Work today is more complicated than ever. The old ways of training cannot get new employees up to speed as fast as the experienced people are retiring. We need a better way forward. Introducing Dynamics 365 guides. Simple step-by-step instructions are easily written on a PC, and then holographic parts and icons are simply picked up and placed on the machine where the work is happening. From day one, employees are often expected to get work done, but the complexity can be overwhelming. Now, employees can learn by doing. This is a tool that works with existing processes, allowing a manager to get the right guides to their people. The instructions move with the employees, pointing them to the tools and parts they need, showing them exactly where they need to apply them. Employees get up to speed faster, with fewer errors and more confidence. A simple glance moves them through the instructions, meaning their hands are free to do the work. They can learn at their own pace without having to rely on other workers around them. The overall experience is comfortable and intuitive. For the first time, a manager can see detailed information about how the employees are working and how their skills are growing. This makes continuous improvement faster than ever before. All of this helps employees make the complex simple, so they can learn and adapt faster, and organizations can stay competitive.
So that was an example of how augmented reality worked in a manufacturing environment. We also have customers like ASML have used this to deploy HoloLens across their semiconductor customers in Asia because of their inability to travel and supporting the huge expensive machines that are on the semiconductor fab. And how do you support operations through remote assistance with the HoloLens 2? The next area is operational intelligence, where we're trying to get data from the plant to drive end-to-end visibility, real-time monitoring, predictive alerting, prescriptive recommendation. And all of this is driven by our IoT, digital twins, and also leveraging our data and AI platform. Some of this capability can be described through an example here at Jabil, where in Jabil, we were able to connect to machines in the shop floor in the PCB production line. And as a result of connecting to these machines, we were able to look at the optical inspection specifically on PCB boards, looking at the geometry and the placement of components and detect problems in that. So what was earlier a camera-driven process, we are now connecting that to an edge-based machine learning capability where we're able to detect 560 images per second and provide that real-time capability and ensure that you have reduced number of false positives, reduced amount of rework and operative processes, and thereby improving the quality and improving the productivity of the line at Jabil. I'd like to play a quick video to explain how this works at Jabil.
People tend to think of Jabil as a contract manufacturer. We are more than that. We're a manufacturing solutions provider. It's a very difficult business. We help customers with taking a product and building it at scale.
We went to the production site and found out the test machines suffers very high false call, around 30%.
Operators have approximately 2 seconds to analyze each one of these images. For some of the boards, they can have upwards of several thousand components on it.
Human gets tired constantly staring at the same stuff. We thought that was a very good opportunity for us to use deep learning to classify images. The model is actually reducing the workload for operator. For model training, we're using Azure Linux GPU VM, and we're using Azure Machine Learning Services to deploy the model as Docker container. Our pilot is predicting 75% of the past images and can correctly predict 92% of the defects.
It's one of the most advanced predictive projects that we've had going on so far. We've been talking with Microsoft about Project Brainwave.
The early test result from Microsoft has shown FPGA is capable of predicting 550 images a second, comparing with a CPU cluster with 40 images a second.
The potential for Project Brainwave is substantial in allowing us to move forward at scale for machine learning across Jabil. Very exciting.
With that example, I'd like to move on to the next area, which is process and workflow automation. This is empowering workers with the tools to connect all their line of business applications with the shop floor, whether it's work instructions, whether it's quality control processes, whether you're driving lean process management. And this is becoming more and more relevant today when you want to move into a paperless operation on the shop floor. One example of this in a COVID scenario is how do you get people back to work and return to workplace more safely. So this is a very quick video that shows you how this happens.
Returning to the workplace during a pandemic. It's a scenario very few of us have faced, until now. The Microsoft Power Platform empowers safe reopening with the Return to the Workplace solution. Supported by Power Apps, Power BI, and Power Automate, this low-code solution is designed for everyone. Location readiness allows leaders and task forces to quickly make informed decisions using criteria like infection rates and supplies availability. Employee health and safety management empower employees to check in remotely and self-screen before entering. Workplace care management provides health and safety leaders tools to identify potential infections, manage cases to ensure care and quarantine, and notify exposed individuals. And location management help facility managers monitor occupancy, health supplies, safety procedures, and other facility-related best practices. We all want to get back to work and back together safely. Learn how Power Platform can help you return to the workplace with confidence.
So that was an interesting video on how we're enabling workers to come back to the workplace and still remain safe through all the software-driven automation that is possible in manufacturing. Lastly, we'll cover the resource optimization area, the ability to create digital twins, getting into more advanced areas like process modeling, asset modeling, production plant simulation, process optimization, and training. So when you look at digital twins, we look at them from 5 different perspectives, from configuration to asset to process, performance, and simulation, across a variety of line of business you can look at, from maybe a product or a service or a factory or a supply chain or a smart building. And when you look at this from an example that's shown here of a power plant that has multiple turbines in the power plant, and within those turbines you have multiple configurations, and within that configuration you have a fuel pump, which is item number F as is shown. So first of all, from an R&D perspective, you might do what is called a simulation twin, and that is driven by R&D tools such as simulation tools. Then we look at that particular asset where the asset is in 3 different configurations. So that creates an asset twin that goes into your maintenance systems, that goes into your ERP, that defines what that particular asset is as configured in the plant. Then we get into a performance where you start looking at that turbine and start to get performance data from the turbine through IoT sensors and trying to understand what is going on with the turbine to be able to provide guidance to the operator and improve the performance, and if necessary, provide maintenance support for that turbine. Then we get into areas like a configuration where the configuration is defined as shown with the bill of material structure here. So different configurations as sold, as service. So this becomes more relevant from a service scenario where you have a service change of one of the components as shown and how that changes that configuration of the turbine. Lastly, when you combine the entire thing together, it creates a process twin of the power plant that gives you the ability to model the plant and make changes offline and push those changes down to the shop floor. We'll now move on to autonomous systems where we're trying to use deep reinforcement learning to create AI-driven decisions for process optimization, for machine calibration, for motion control. And this is driven by our acquisition of a company called Bonsai. Over the last 18 months, we've been pushing this more and more in manufacturing by creating a concept called machine teaching, where we take subject matter experts or engineers and use their knowledge to train models, create those reusable concepts, and create explainable policies that can be pushed down to manufacturing. One example of this is in an oil field supplies company, where is New Well Oil Warco. And here they're able to look at a CNC machine and how do you fine tune a CNC machine where you needed an experienced CNC operator, where we were able to implement our system, autonomous AI system, to learn from the operator and then get to tuning the CNC machine within the same degree of tolerance or even better tolerances in a shorter time frame. So what used to take an hour or so, we managed to compress that to about 15 minutes using an autonomous AI solution. Lastly, I'd like to touch upon security and compliance, which is a critical part of manufacturing. As companies emphasize more and more on IT security, an area that is important is the shop floor security, where you have so many different devices that are connecting. You have PLC systems that are exposed, where anybody could come in with a thumb drive and plug it in, where we're now getting exposed to more viruses that are attacking or more hackers that are going after the factory and trying to disrupt factory operations. So here is where we're spending a lot of time in ensuring that the factories are safe. So with our acquisition of CyberX, we have the ability to do agentless security for unmanaged IoT and OT devices. So it's purpose-built for OT security with the knowledge of all the OT protocols across a wide variety of suppliers, with OT-focused threat intelligence team called Section 52 that monitors all the OT threats globally and is able to provide warnings to our customers. With that, I'd like to conclude my session on intelligent manufacturing and hope you're able to take away key points from my session in terms of how you drive intelligent manufacturing and essentially driven by, like I said, the convergence of IT and OT using the machine learning platform and also process automation. All of them driven by the sensor level data, the IoT layer pushed into the IoT hub, and then driven through a data and AI platform that creates value and creates an intelligent manufacturing organization. Thank you very much.